Thank you so much. I'm really incredibly honored to be invited and delighted to have the opportunity to spend the day here. It's been just a fantastically inspiring and interesting day talking to many of you. I want to start by pointing out that you have to read my title extremely carefully. George actually said to me this morning, "Aren't you speaking on a theory of software design?" And I said, no, it's towards a theory of software design, which means I wish I had one. But this is going to basically tell you about my evolving thoughts about what a theory of software design would look like. And it's a topic I'm very excited about, even if I can't claim to have made the progress that I hope eventually to make. So let me start by saying a little bit about how I got here. It was really through a kind of midlife crisis. When I started rethinking my assumptions about everything I'd done in my career. As Yuri mentioned, I developed with my students a modeling language called Alloy. And we had a nice shiny orange book, which got reissued in its second edition as a green book. So now everyone has justification to buy another copy. And Alloy was a quite unconventional way of viewing the verification problem. If you think about the traditional view, that, to put it incredibly naively, is basically that the quality of software amounts to the correctness of the code. The Alloy project sort of moved in a slightly different direction. So the first direction was that I advocated what I called lightweight formal methods and formal models, where you would use the power of automation in a way that didn't require enormous manual theorem-proving efforts. I advocated focusing on designs as well as code. Most of my research has been about checking designs on the premise that if you can find bugs earlier in the process, then that's a good thing. And then something that actually I discovered with my students when we actually built Alloy, almost as an accident, is that the whole verification project had been basically premised on the idea of certifying things that were already correct. And we, along with many other people, discovered that when you build a tool that allows you to generate sample executions, the value of exploration is sometimes even higher than the value of certification. But now I'm wondering about all this. One of the things I'm wondering about is that an assumption behind Alloy was that every little detail of your design really mattered. And that it was, what you really needed was a tool that would catch every little detailed error. And I'm asking myself, well, do these details really matter that much? A more interesting way of looking at it is, well, maybe details matter, but maybe these were the wrong details. And in particular, are we looking under the lamppost? In other words, are we looking at the things we can analyze rather than the things that really matter? So I'm going to tell you a little bit about how my point of view has shifted by showing you essentially a software development model. But before that, I want to give you a little story. So Dropbox is a great tool, and I'm sure many of you have used it or use it, but it's not always perfect. And here's a Quora question that caught my eye. Someone accidentally deleted thousands of files in my company Dropbox. How can I quickly undelete them? And I love this because you know this was not written by a computer scientist, right? Because the optimism in the word quickly is just so unrealistic, right? They should be saying, is there anything on earth that can be done to at least save some of my files, right? But this person not only wants to have them back, but wants them back quickly. You know, I mean, what planet are they on, right? And if you look in the web, you'll find lots of blog posts of people who tell you that sharing things through Dropbox with people is very dangerous. So why is it dangerous? Well, let me give you a little scenario. So Alyssa and Ben, let's suppose, are planning a party. And Ben creates a Dropbox folder called Party for the party planning, and then a subfolder called Invitations that he's going to put the invitations in. And then he chooses to save the party folder with his friend Alyssa. So he says, share the folder with her. Now Alyssa comes along, and Alyssa is in fact going to arrange the food for the party. So she's not interested in the invitations. So the first thing she does when she sees this nice shared party folder is she goes inside and she sees the subfolder marked invitations. Note, by the way, it's interesting that the party folder was marked with two little stick figures. You saw that? I guess that was Alyssa and Ben, right, sharing the party folder. The invitation folder actually is also shared, but it's inside the party folder. Alyssa doesn't need this folder, and she's worried that Ben, this folder has tons of stuff in it that she certainly doesn't want to waste room on her disk for, so she goes ahead and deletes that. And so when she clicks on the delete button, she gets this message. Are you sure you want to delete invitations from your Dropbox? And of course the answer is yes, of course I'm sure. So she deletes it. Now, when she's actually finished organizing the party with Ben, she decides, well, it's time for party to go as well. So she deletes that. And it says, are you sure you want to delete party from your Dropbox? And she says, yes. So here's my question for you. First of all, how many of you are Dropbox users? All right, almost everybody. I won't ask you what happens in these two cases, but how many of you are completely confident that you understand the behavior of Dropbox in these two cases? Oh, that's wonderful. OK. So you're not alone. So I had an undergraduate researcher, Kelly Zhang, and she actually did a little survey amongst 50 or so MIT undergraduates. And she asked them to self-classify according to their knowledge of Dropbox. And then for these two scenarios, basically to explain what happened. And you can see that very few of them actually knew. Certainly the ones who admitted they had poor knowledge. In case of deleting a shared folder, that would be the party folder, none of them got it right. But even in the case of those people who classify themselves as having good knowledge, fewer than 60% knew that deleting the party folder would simply unlink it. Although a larger number knew that deleting the shared subfolder would actually remove it and destroy Ben's copy as well. So I'm very interested in this kind of thing, trying to understand what the root of this problem is. And my contention will be that this is something fundamental in the design of Dropbox. But first, let me take a step back and talk about the big picture. So here's how I think about the software problem as traditionally conceived. You start out with a customer who has some unarticulated needs. And from that, you elicit some requirements. You then build some specifications for the software components, and then some code. And we have names for each of these activities. We call the first step elicitation or requirements analysis. The second step we typically call design or architecture. And then the third step, implementation. And then we have ways of talking about checking that each of these steps was actually a sound step. So we use the term validation typically to talk about whether or not your requirements actually corresponded to the needs. Perhaps design checking. I'm actually not sure whether there's a standard term for that. Sometimes verification. But verification is most commonly used to talk about the relationship between these things. Okay? Now, some things to notice here. The first is validation obviously has to be informal because the needs aren't even articulated. Design checking can be formalized, and that's basically what I made my career on. That's what Alloy was all about. The other thing I want to note is that in the traditional formulation, both the requirements and the specifications are essentially constraints on the behavior of the software. And I think that's a widespread assumption, and I want to argue that that's actually a mistake. OK, so let's imagine a particular example. Suppose that you are designing a ticketing system for the MFA in Boston. So what would your requirements and specifications be? So your requirements might be things like everyone inside the museum holds a ticket, and every ticket has been paid for. And then I could do, using a tool like Alloy or many other design level tools, I could do analysis to show, for example, that a consequence of these is that everybody who is inside has paid to be inside, for example. And then I could have specifications that say, for example, when a ticket is bought, the credit card is charged, a record is written, and the ticket is issued, and then you can enter through a turnstile if the ticket is valid. And I could build a little architecture that has the ticket desk and the entry style with the appropriate communications. And now I can consider the kinds of flaws that this model of development would expose. So one flaw, for example, that sits in this elicitation phase is that maybe these aren't the right requirements. I didn't, for example, include the possibility of there being staff who work for the museum who certainly don't need tickets to be inside, right? And what about people with press passes? Well, they typically need tickets, but they don't need to pay for them. Or how about families? Well, families, maybe they pay for their tickets, but there's one ticket for the whole family. So I realized that these requirements aren't quite right. The mistakes at this level, essentially flaws in the architecture. Maybe I don't send this record. I don't ensure that the record message is sent quickly enough. And so maybe if the database is slow, a customer could actually get to the entry style before the record is in the database, in which case their ticket will appear to be invalid. And then, of course, there are verification errors. For example, maybe I'll fail to make the charge and record action atomic so that it's possible if the credit card fails that you still get a ticket, or vice versa. So those are a bunch of errors. But there are a bunch of very different things that can go wrong with a system like this. So, for example, you could have ticket forgery, right? That people come in with fake tickets, or that people transfer tickets to people, or maybe a child buys a child ticket and then gives it to an adult. You could have scalping, right? You have an important show, and a limited number of tickets, someone comes in and buys them all and then sells them again to a higher price. Or you could lose your database and then find that because your database was a single point of failure, now you have to reissue all the tickets because you have no way of showing that the tickets that have been issued to date are actually valid. So my contention is that these are very different classes of errors. That this class, which is the class that I basically focused on in all the work I did in Alloy, it's true that you've got to get these right. And it's true that getting them right is very tricky and depends on the details of the requirements and the specifications and so on. But I would argue that they're not necessarily the most important ones. And in some ways, these kinds of flaws matter more, right? Because those are the ones that typically actually undermine these kinds of systems, right? For one thing, these kinds of errors are normally fixed quite easily. These are much more fundamental errors. So what's the root of this problem? Well, I would argue that the root of this problem is that what we actually did was premature design. That when we wrote down those requirements and we said everyone inside holds a ticket, that wasn't a requirement of the system. That was a huge design decision, right? We were saying basically we're going to use a ticketing system to solve whatever problem the museum has, and we're going to do it by issuing tickets. And there was no reason to believe that, right? And so we rushed into a design with all the potential problems that the design has. So I would like to think about the problem differently. Instead of having requirements and specifications between the needs and the code, I'd first of all like to articulate the needs as a collection of high-level purposes. And then I would like to invent what I'm going to call concepts to fulfill those purposes. And the concepts will be characterized by individual concept purposes and then concepts. So for example, my purposes for the entire system might be, I go to the museum director and say, well, why do you want this system? And she says, well, I'd like to balance the budget. We're not getting enough money in. Or I want to grow attendance. Or maybe I just want my customers to be satisfied. And then from there, we can consider sub-purposes, such as getting the visitors to pay or limiting crowds. And then the concepts that actually are motivated by those sub-purposes. So for example, if I'm interested in getting the visitors to pay, maybe I'll achieve that with tickets. Or maybe I'll achieve that with the kind of little metal buttons they used to have at the Met in New York, which is a similar scheme, but not an identical scheme, and actually has quite different characteristics from a design point of view. The buttons, for example, being much more transferable. So in this scheme, the important thing to note is that the purposes, the first thing we articulate, are no longer a design. And that's important because it gives us the space then to actually consider design options. And these are the designs. And the problems that then arise are actually now problems that we can actually articulate because they've become internal to the process. They're problems of the choice of design against the actual purposes that that design was intended to serve. And I call these misfits, to use a term that Christopher Alexander invented, actually in his PhD thesis. You probably know him as the inventor of the idea of design patterns. He's, as everyone's called him, he's every computer scientist's favorite architect. Apparently, architects aren't quite so enamored. I don't know why, because his buildings seem to be great. But he's certainly well known to computer scientists. And he wrote this wonderful book based on his thesis called Notes on the Synthesis of Form, in which he really talks about the requirements problem and this problem of how you can actually characterize your needs in such a way that you can eliminate all these possible misfits. His conclusion is actually a very depressing one. It's basically that you can't. He says, such a list of requirements is endless, but think of them as a negative point of view. Write down the things that might go wrong, the misfits you know. And he describes these misfits as the relations between form and context which obtrude most strongly, which demand attention most clearly, and which seem most likely to go wrong. This has been very inspiring for me as a way of thinking about how we could come up with better ways of designing software, but also recognizing that the design process indeed has these fundamental limitations. So how do you actually prevent misfits in a software context? Well, the first thing I think you need to do is you need to avoid premature design, because you're going to make design mistakes if you design when you don't even know you're designing. And I would argue that conventional requirements are often premature designs. In fact, if you're familiar with the way design often happens in industry, someone will say, well, that system was so big it had 50,000 requirements, right? what they actually mean by requirement is often something nearer to a state transition. So they're way down there in the component specifications. So the view that I gave of requirements is a rather academic view, which I think is a lot better, but it still has the liability that that kind of requirement, everyone inside the museum holds a ticket, is really a premature design. The second thing I think you can do is analyze the concept design. So you can actually look at the design and ask yourself the question, is this a good design? What's its mechanism and what's its purpose, and does it serve its purpose? And then the third thing, not surprisingly, is you can learn from the past. And here I think that concepts could be a potentially powerful way to do this, because they allow a decomposition of the system in which you can more readily recognize bundlings of functionality that have been used before. So the notion of a ticket is exactly that, right? If you think about it, when a lot of computer scientists would write a paper about, a ticketing system, and I'm guilty of having done this kind of thing before myself, nobody would say, a ticketing system? Like, we've seen those before. There are a million of those, right? Why are you describing this as if it's something novel, right? We should already know all the ways in which ticketing systems have failed. How can you even write a paper about a ticketing system in which you don't take into account all the ways ticketing systems fail? And yet we've sort of become acculturated to a view of design that everything has to be completely considered afresh. So you're probably wondering, well, what the heck is a concept? So I've told you that I think a ticket or ticketing is a concept, and I want to tell you a little bit more now about what a concept actually is. So I think of a concept as being composed of multiple parts, representing different aspects of the concept. So the first is the data model. It's essentially what the concept is about, or if you like, the state of the concept. So for a ticket concept, for example, it would be the set of tickets, and maybe if we're going to track the ones that are being used, if they're tickets that can't be reused, maybe the ticket has some range of dates for which it's valid, a resource for which the ticket applies. It says maybe you can gain entrance to this particular show. It has a customer who's the holder of the ticket. Whether or not that's actually represented is going to influence whether the tickets can be transferable and so on, and maybe a price. So that's the first aspect. The second aspect is the purpose, what the concept is for. So I said that the purpose of the ticket concept was to get visitors to pay. That was certainly the motivating purpose, but when you actually think about the particular design, you can often understand the design of your concept in terms of a more interesting purpose, a purpose that distinguishes that concept from others. So, for example, for the generic idea of a ticket, it might be to separate the use of a resource from the granting of the use, right? If you think about it, that's a fundamental reason to use ticketing, right? You can have a ticket desk and an entry turnstile, and you can separate them. You can even issue your tickets online, right? And that's a very important reason to use tickets. The third part, what actions the concept involves. So they might be user actions, such as the customer actually using the resource, going into the museum, system actions, like validating that the ticket is valid, or joint actions, exchanging money for a ticket. And then what brings it all together is what I call, borrowing a term from the philosopher Michael Polanyi, the operational principle. And the operational principle is an archetypal scenario that puts together the actions to explain how the purpose is fulfilled. So in this case, it might say that the user requests that the system issue a ticket. The user presents the ticket for validation, and if the validation passes, the user can then use the resource. So this is a generic one, and of course I can specialize it for the museum if I want to explain to a museum user how it works. You put some money in, the machine gives you a ticket, then you insert the ticket into the turnstile and it lets you in. Now, you might be saying, well, this seems pretty obvious, right? I mean, this is just like a use case or a trace or whatever. But I think there's something fundamental here, which is that as computer scientists, we've always had the assumption that if I gave you a state machine, right, and that language had a well-defined semantics, then I've essentially explained the mechanism to you, right? Well, imagine if somebody gave you a state machine in Microsoft Word, you wouldn't be enlightened, right? It wouldn't actually help you to use it. And furthermore, the way that a lot of companies explain their products wouldn't help you either. If I told you what every menu entry did in Microsoft Word, that wouldn't really help either. The point at which you understand something is when someone connects a sequence of actions to fulfilling a purpose. And so that's an important aspect here, that the operational principle is an archetypal scenario. It's the scenario, the successful scenario, that explains how a user will make use of this concept to fulfill the purpose. And I actually think that there's a lot to be understood about the role of such operational principles as explanations. And Michael Polanyi, who doesn't, I should say, advocate operational principles in this form, this is my sort of translation of his idea into software, he talks about it as in a much more general abstract way, but he argues that this is the essence of engineering. As he puts it, engineering includes the operational principles of machines. Physics and chemistry, on the other hand, include no knowledge of the operational principle. Hence, a complete physical and chemical topography of an object would not tell us whether it is a machine, and if so, how it works and for what purpose. So the way I like to imagine this is imagine a thought experiment in which you took a 19th century logician, maybe Charles Peirce, right, or maybe a little later Bertrand Russell, or whatever, right, and you took this logician and you put them down in front of Facebook, right, and they said, what's this tagging thing? And you said, well, no problem. Here's a description in first order logic, right? The question is, would that actually satisfy them? And what Polanyi is basically saying is that wouldn't help at all, right? You could have a perfect characterization of the behavior, but if you didn't understand how tagging actually fulfilled the user's needs, then you wouldn't be explaining a machine. So to summarize, the ticket concept is made up from all these parts. And I'm building basically a catalog of reusable concepts that includes not only these parts, but also a section on variants. So we might have tickets that are transferable, repeating, and so on. Sample uses, known misfits, and relationships to other concepts. So for example, the concept of ticket is related clearly to the notion of a reservation, which is another well-used concept. And sometimes they're combined. You can have a ticket for an exhibition that says you can only use it between 3 and 4 o'clock. So I see that as an instance of like a merged, composed pair of concepts. So now if we go back to Dropbox, we can understand Dropbox in terms of concepts. And my contention is that the problems that people have understanding Dropbox are not part of Dropbox. They go way back to the earliest days of Unix and even Multics before that, to the notion of a folder. So the concept of a folder has the purpose of organizing files with local namespaces. And we're familiar with the data model for this, but the data model is actually really weird. And what's weird about the data model is that a folder has associated with it a set of entries, and each entry has a name and the entry links to some object. And what's strange about this is that there are two things that are strange about it. One is that deleting an object corresponds to deleting this link, right? Essentially taking it out of the folder it's in. And the second thing that's strange about it is that the name essentially belongs to the folder and not the object that it's pointing to. So we can have the operational principle, which is, as you know, how path names are constructed, how you find things in folders. But this design leads to some fundamental misfits. So one of them, for example, is that as a naive user, you might think that if you delete a file, that basically means you've destroyed it. But of course, that's not the case, because as I said, deletion is elimination of a link. And so in Unix, deletion is when you remove the last link. How do you know it was the last link? Well, you don't, right? So that's pretty weird. And that's a complication. Another one is this notion of naming means that if you change the name of a file, typically it's treated as a new file. And we know all the problems that creates in version control systems and backup systems. Rather than telling you, you changed the name of the file, it says, oh, you deleted the file and this other unrelated file appeared. We could do the same thing for a synchronized folder, which I think I want to sort of skip over the details of this, but we're all familiar with this idea, right? The purpose here is very different. It's to allow you to have copies of the same file on multiple machines. And now we have new misfits, right? In particular, propagated deletion. If you accidentally delete a file on one machine, right, it's gone from all your machines, right? So again, notice that as a misfit, this isn't like a verification property that's violated, right? The specification says that deletion should be propagated because the purpose of the file synchronizer is to allow you to organize your files on one machine and then have that organization happen everywhere. But as anybody knows who uses this kind of mechanism, this is a catastrophic design flaw of synchronization, that if you do an accidental deletion, then you will lose the file everywhere. And likewise, temporary files that you might not have intended to get propagated, for example, that contain secret data, present a similar kind of problem. And then we get to shared folders in Dropbox with a more complicated model in which now entries include not only links to files, but also files that are mounted. And that creates new problems And I would summarize the problems we were talking about essentially with the misfit, the sort of all-purpose misfit, that in Dropbox you can't share a subfolder. In fact, it turns out that in a business, pro, more expensive version of Dropbox you can, but that has its own problems. If Ben wants to share the party folder with someone, he can't then choose to share just the food folder with Alyssa, right? Because you can't share folders that are in a hierarchical relationship to one another. And there are various workarounds for this in Dropbox. For example, there's a notion of selective sync, where Alyssa could have said, well, I want to remove my view of the invitation folder. But the point is that this notion of shared folder basically has these misfits. So we've got these concepts. How do we evaluate them? And in a sense, this is the center of any kind of design method, which is if I come up with designs, how am I going to know before I actually realize the design whether it's good or not? So I've thought about this a lot, and with my graduate student, Santiago, we've come up with all kinds of attempts to capture things like orthogonality of concepts, completeness of concepts, and things like that. But we actually settled on one property that we think is quite crucial and quite powerful in its explanatory power. And that is that in a well-designed system, each concept has its own purpose. And there's just one of them. So that means that basically purposes and concepts are mapped one-to-one. And you don't want any of these things to happen. You don't want purposes that have no concepts. That's pretty obvious. That means you didn't get what you wanted. You don't have concepts that have no purpose. And you don't have redundant concepts, two concepts for the same purpose. And you don't have, this is the most controversial one, you don't have overloaded concepts where a single concept is designed to satisfy two purposes. So I'd like to illustrate this by showing you what I call some happy concepts and then some sad concepts. Okay? So first, happy concepts. So here's an example of a happy concept, the Macintosh trash, which, of course, now is in Windows and everywhere, right? So what is the purpose of the trash? This is an audience participation moment. A temporary delete. That's the crucial point. And the crucial point is temporary, right? It's to allow you to undo of deletions. And of course, one of the things I think is interesting is that although people are often given the idea that the trash is somehow a virtual analog of a physical trash, of course, it has a completely different purpose, and naive users don't understand that. I probably don't want to undo deletions. Maybe that trash can, but the trash can out in the street, I probably don't want to undo deletions from, right? So analogies only go so far. So then, of course, I have the operational principle that says, what you'd expect. If you delete a file, it goes in the trash. You can restore it from there. If you want the space back, you empty the trash. But this is what I would call this is a concept that we all like. It's very successful, but it is a concept with misfits. Here are two. One of them is, if you put a USB key, for example, into a Macintosh laptop, and you try and move a file to it and there's not room, right? What do? Well, you select the files on the key and you delete them. What does that do? It puts them in the trash. So now is the room on the USB key? No, there isn't. So what do you have to do? Empty your trash. Do you want to empty your trash? Oh, no, you don't, because you've still got a terabyte of space on your disk. The last thing you want to do is to lose the ability to restore all those deletions you've been doing for the last 3 years, right? So this is actually kind of a bad misfit. Another example of a misfit, late at night, you're deleting files, cleaning things up when you really should be asleep in bed, right? And you hit a file, say delete, 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 and then you say, oh, now I remember why I wanted that file, right? Can you find it? No, because you forgot the name, and you can't sort by deletion date. So you're hosed. Well, it actually turns out that Apple solved that problem about 3 years ago by adding a piece of metadata when a file or folder was added to a folder. So that solved that problem, but it was at least 20 or 30 years that problem was not solved. So that's a happy concept. Another concept I want to show you, because I think one of the fun things about this project has been trying to think about the most fundamental concepts that people use and that arise and that happen in all kinds of applications. And so I somehow played this sort of philosophical game of looking for the most tiny fundamental little things that we take for granted. One of them is the concept of selection. So that arises, for example, in this slide preparation tool, I can select multiple slides. in Lightroom, you can select multiple photos. In Apple Mail, I can select messages, and so on, right? So this is something we're completely familiar with. But what interests me about this is that this concept of selection, like many concepts, is actually surprisingly intricate. And it's actually a very beautifully and carefully designed concept. But actually, first I should say it's interesting to ask what its purpose is. So what do you think the purpose of selection is? Yes, it's basically to aggregate the application of a function or an action to multiple objects. That's right. And actually, to make that actually work, you have to do some clever things. So one example, if you look on the Mac, you can have things selected in multiple windows. Now the question is, when I apply an action, what subset does it get executed on? You can try that to see what happens. Another is, what do I do with an action whose semantics only make sense on a single object? So that's normally handled by what I call active element. So here you see these 4 photos are selected, but this one is slightly brighter. Right? So this is another scheme that's common with selections, that there's a selection set and one member of that set that's more important. Here's what I think is a particularly beautiful subtlety in the selection concept, and it's really absolutely at the core of the way Photoshop works. So suppose I had this photo in Photoshop and I wanted to eliminate the background. So the way I could do it is I could draw around my statue, and then I could tell Photoshop to select the pixels inside the boundary. Now, if you do that, you can go into a quick mask mode, and you can actually highlight the pixels that have been selected. And what you'll see is that there's actually not a digital, a binary drop-off here, but a gradual drop-off. This is what Photoshop calls feathering. And the reason that's important is because then when you apply, for example, the operation that lightens or darkens the pixels, it's attenuated by the feathering, with the result that you don't get a nasty, sharp transition there, right? So basically what's happened here is that the notion of selection is now a real number between 0 and 1, rather than 0 or 1. And then my final example, when you select things inside folders, and you can also select folders, this gets pretty interesting. So in Google Drive, for example, if you select a folder, it's just the same as selecting its children. But in many backup programs, such as CrashPlan, if I select a folder, its semantics is subtly different. It means include the children and any new objects that might become children in the future, which I think is pretty interesting. And so you can do a similar kind of catalog entry for selection, describing its data model, its actions, the different kinds of variants it has. I actually had trouble coming up with a misfit. Maybe the only misfit I can think of is that accidental deletions, if you don't have undo, are pretty bad if you can select a lot of things. So those are the happy concepts. Now the sad ones. First one, categories. So Gmail has this nice notion of categories in which basically it filters your incoming mail into mail that's supposedly for you and mail that's promotions and social media and so on. And then you can customize the settings, choosing, for example, which categories appear on which tabs. When this came out, the blogosphere was not entirely happy. It was described as super confusing, really ugly, stupid, and unnecessary. People said Google gets it terribly wrong, and this new feature is a disaster. And this guy certainly does not seem to be happy. So I think this is perhaps a little bit of an overreaction. But the question is, what's the root of the problem here? I think the root of the problem here is that people already had labels, and they didn't understand why categories were necessary. Not only were labels a way you could organize your messages yourself, but you could have system-assigned labels. And Google was already doing that. So why wasn't this new feature of classifying your email built into a concept that people already understood? And I'm actually not a Gmail user, so I was curious to learn about this, and I looked up label in Gmail's help facility, and it told me labels help you organize your messages into categories. So you can see there's a little bit of editing to be done on this entry. The key point here, though, is that this isn't just a philosophical nitpick. It's not just the psychological confusion of two concepts. It's there are things you really can't do. You can't associate tabs with labels. You can't use tabs outside the inbox, right? So the fact that Google chose to introduce a new concept with different properties actually impacts the features available to the user. And I call this an example of redundant concepts, where basically the purpose was to classify messages, could be described obviously in more detail, but that's its sort of title. And there are two separate concepts when there really should be one. Second unhappy story. This is a lovely camera that Fuji made as a kind of Leica killer, like a tenth of the price of a Leica, with manual controls, but also a lot of software in it. So you could change the image quality, for example, from RAW to fine plus raw. And what this means is I want to store not only the raw sensor data, but also a high quality JPEG. So you get two files from every image. So, and you can use that, and you can see it tells you what the setting is somewhere I don't see on the screen. So, oh, up there on the left it says raw and an F for fine. So, one of the cool things this camera can do, which turns out to be photographically very useful, perhaps surprisingly, is that you can change the aspect ratio. You can decide that you would, rather than taking a photo like that, you'd like to take a photo like that. You'd like to be an Instagrammer all your life and only take square photos. So how do you do that? You do that by going to the image size menu and switching from 3:2 to 1:1, okay? And so now we're in a state in which it says this is our image quality and this is our aspect ratio setting. Okay? So now my question is, what would happen if I decided that I didn't want JPEGs in the image quality? So the answer is this. If I go there and I change it to just raw, it does this. So notice that my aspect ratio setting has been lost, and it's put that little gray thing saying raw there as if to tell me, nah, can't do that anymore. So why do you think that might be the case? There's no good reason, actually. Yes? That's right. And you might think that the cropping, the aspect ratio was just a crop that was performed in the post-processing to create the JPEG, right? Well, so this is a conceptual design problem because it means that you can't get what you might want here, which is just raw photos with your choice of aspect ratio. However, it turns out that is not true. If you actually look at the raw images that are produced, so here's a photo I took. Actually, this is a very nice projector, so you might even be able to see this the way I can. Can you see that the selected area is like a little crop box here inside the image? So there are actually pixels outside here. So what it gives me is it gives me a raw image with metadata that shows the crop. So there's no reason not to offer this feature in that mode. It just fails to do it. So, so I think the New Testament explains this very well. No one can serve two masters. Either you will hate the one and love the other, or you'll be devoted to the one and despise the other. And this is true of concepts and purposes. When you design a concept, it can only satisfy one purpose. And you're going to be in trouble if you try and satisfy two. And what was going on here, I'll tell you about in a minute. But I see three ways in which this kind of overloading can happen. Piggybacking, false convergence, and emergent purposes. So let me just mention these briefly. This camera is an example of piggybacking. I think this is my reading into what happened. They had a menu here. This menu was actually a menu for choosing how fine-grained the JPEG is going to be, because you can see large, medium, and small here, and the number of images you're going to have left if you choose those settings. And someone probably said, I can just imagine them, someone said, wouldn't it be nice if we had an aspect ratio feature? Someone said, well, you know, we already have a menu that allows you to choose the dimensions in pixels of the JPEG. Why don't we just piggyback on that? And so they said, oh, sure, let's throw it in. And there it is, you see. So now we have three aspect ratios associated with each of these, right? And you can see that when you choose some aspect ratios, you'll get more images because the JPEG will be smaller. But of course, that wasn't good for the user because choosing the granularity of the JPEG and choosing the aspect ratio were really different purposes. Here's another example. My Epson driver has a paper size concept where you choose the paper size. If I look at my options for US letter, they include US letter manual front and US letter sheet feeder borderless. So what's happening here is that Epson has piggybacked onto this one concept two purposes. One is to choose the size of the paper, and the other is to choose the paper source. And I don't want to get into details, but maybe you can imagine, I'm happy to tell you, bore you endlessly. This causes terrible, terrible problems because different applications rely on paper size in different ways. And this really screws things up big time. Here, yes? Right. Right.
Wouldn't that be okay?
It might be. In fact, if we have time, I have some slides on exactly that question of trying to achieve engineering efficiency. I guess my argument is that more often than not, that's done in engineering in order to save resources, and that in software we don't need to save those resources. And that a better presumption is to start out by having a separate concept for each purpose. And if you're then able to merge two concepts in a very elegant way, that would be desirable. But it's generally it's a sign. It's a bad smell, let's say. So this isn't an immutable design rule. It's a sort of bad smell. Sometimes two purposes look the same, and it occurred to me that when I'm asked, for example, to write a review of some of the people who work to me, and I'm asked to provide for this review form, both to be for a performance summary and for goal setting, that these are two purposes in conflict with one another. You cannot sit down with someone and have an open discussion about their goals and encourage them to improve their career while at the same time sitting in judgment on their performance. And I believe we do exactly the same thing with conference reviews. Right? And you see that all the time. You cannot write a review that attempts to convince your colleagues to accept or reject the paper while also providing useful feedback. These are fundamentally different objectives. Here's another interesting case, I think, where this happens, that a purpose sort of emerges. Think about subject headlines in email messages. So if I had to say it, I guess the initial purpose of a subject header was to summarize the content of the message, okay? But then people started using it for different purposes. So, for example, listservs would start putting the name of the listserv in the subject to allow people to sort it. And this means that you're now using the subject for two purposes. And as Sriram Krishnamurti pointed out to me when I told him about this idea of having two purposes for the same concept, that this is exactly that kind of problem. And he pointed out this delightful misfit that actually someone in his department BCC'd a bunch of people, including a list. And then, of course, the list appeared in the email message to everybody who got it. So his intent was that BCCing would hide the group of people he was sending it to. But, of course, the BCC feature completely messed that up. And then a similar thing happens in Gmail, for example, that now subjects are used for grouping by conversation. And there are many misfits associated with that. My final example of an unhappy concept is this. This is a character style dialog from Adobe InDesign. And this is used in order to systematically style some bunch of text in different places as having an emphasis. And I've chosen that by emphasis I want to italicize. And notice that the font family entry is empty. So my intent is whatever font you have, I want to italicize it. And the idea of factoring this out is that if later maybe I decide I want to emphasize by underlining or putting in bold, I can do that systematically through the whole document. So now the question is, when I click on the font style box, what other options do you think will come up? Bold, underline. That's what you might think. Well, because I'm a little bit of a font freak, here's what you get when you click on it in my case. Because these are all the font variants for the fonts that I have loaded. And this is actually disastrous, because what it means is that you can't define a style that italicizes. And the reason is that the italic option has different names for different fonts. So for Arno, it's called Arno Italic. For Futura, it's called Oblique. And for Magma Light, it's called Magma Light Italic. Right? So this is an example, I would claim, of an unfulfilled purpose, a purpose that has no concept that actually fulfills it. And the purpose is to allow typeface-independent styling. And what you want is something like a notion of a font subfamily. And that is, in fact, exactly what Apple gave you in Keynote 09. So notice here, the font is not Magma, but Magma Light. And Italic is now an option that can be turned on and off. So Apple basically solved this problem. They recognized this conceptual deficiency. They introduced this notion. They called it font, but it was really a new concept. And then sadly, for reasons I don't understand, when they produced the next version, some smart person said, let's go back to the traditional way of doing it, and now it no longer works. Because now you have to say that the style is light italic, and now everything is broken all again. And that's in fact a repeating theme I've noticed, that when I've looked at particular concepts, those concepts have misfits that were often understood and solved by particular products, and then reintroduced later by people who didn't think, well, this has surely been done before. We should capture that knowledge and then not lose it. Yes, Emery?
Is it possible? I, of course, have no idea if this in fact happened. I mean, it may well be possible that this was a source of confusion, right? So if you look at the one on the left, which is broken everything out, it's all factored out, it's also really big.
Yeah.
And maybe overwhelming.
Yeah.
And they might have identified that the thing that you care about is a corner case.
That's right. I suspect that's true. I suspect that the computation and API difficulties of sorting the fonts might have been part of the problem. I should note that one of the reasons this is complicated is because it solves another conceptual problem. That this one makes it very clear how to apply a partial style. You see, because it's separated, for example, whether it's italic or not, from whether the italicization has been turned on or off. So if I uncheck this, it means leave the italicization as it was. Now, that font thing in Adobe InDesign that happened to be empty, if I click on it, I get a choice of fonts. If I choose one, it now puts the font in. I can now not unchoose it. And you'll find that's a common misfit. The same thing happens in Word. That because they're using standard dialogues and they didn't think about this conceptual misfit, in fact, applying a style partially is something you only get to do once. And once you mess it up, you cannot go back. So Apple tried to solve both problems here, and that produced this extra complication. So you could well be right. There's also a design trade-off. Are you going to do the concept right, as it were, or are you going to take the case that works best for many people? So I wanted to close by telling you a little bit about a project that my student Santiago did to apply some of these ideas to a particular case study. So the way that we thought about doing this research was to basically try and develop this theory while hand in hand working on as many concrete examples as we could get our hands on, and then doing some larger case studies where we applied the theory more systematically across a problem. And so we picked Git because we thought that Git was something that was both flawed conceptually but also very powerful and nobody could claim was a straw man, that it was widely used and very popular. And if you look at the Git webpage, it tells you all kinds of things that I'm not qualified to judge, that it has a tiny footprint, it's lightning fast, has cheap local branching, whatever. But there is one thing that I believe is very questionable, and that is that Git is easy to learn. Now, I think the reason that the developers of Git think that it's easy to learn is because it has man pages, right? This is the Unix attitude, right? And all you need to do is read the man page. So if you want to know what Git rebase is, it just tells you it's forward porting local commits to the updated upstream head. And if you want to know what a wave stash is, it's to wave all stage stashes next to various cherry-picked non-applied applied trees. Or if you want to know what distinguished tree is, well, that's to distinguish a few non-cleaned remote trees inside various rev-listed upstreams. Or how about control stash? That's to control some non-bundled stage stashes over any shown submodules. Now, the truth is, as you might have guessed, these are all fake, except for the first one. But I think they make a point that someone was offended enough by Git's man pages that they chose to make a Git man page generator. And every time you press generate new man page, you get another of these wonderful, incomprehensible man pages. And Git has been the subject, I think, of humor from all kinds of quarters because it really just asks to be made fun of for its complexity. XKCD gives you the essential operational principle for Git, which is that the way you use it, no idea at all. You memorize some shell commands, you type them, and if you get errors, you save your work somewhere else, and you just delete the project and clone it and do that. So we analyzed Git, and in short, what we tried to do was to match known problems with Git against our criteria. So we believe, for example, that there are many concepts in Git that are unmotivated, that have no purpose. So, for example, we think the notion of stash has no purpose. You could not tell a user what the stash is for. Similarly, we don't think you could really explain what the index or staging area is for. And in fact, Git was one of the great inspirations for this whole idea of purposes matched with concepts. Because while we were trying to understand this whole design problem with Git, we asked a lot of people, what is the staging area for? Because it seems to us that it's not for anything. And they said, that's totally wrong. It's for X. And then another person said, that's totally wrong, it's for Y. And then a third person said, that's totally wrong, it's for A, B, and C. And then we realized that was actually a problem, that it's not good to have a concept whose purpose is not clear, where every different user has a different notion of what that concept is actually for. And we suspect that, that things like stashing and staging are really just there, well, in the case of stashing, to mask misfits. In particular, the fact that branching doesn't work in Git. And then we identify what we call overloaded concepts, this idea that a concept serves two purposes. This is actually one I'm kind of curious about because I think it's a problem of all version control systems that we don't know how to solve, which is that on the one hand, you want to group logically related changes. You want to say, this is a moment at which everything is consistent. Remember this. And the other thing is you want to save your files to protect against loss. And now you're in a dilemma, right? Because to satisfy purpose 2, you're like committing every single second. But that's ruining purpose 1 when you really want to commit only very carefully when you're convinced you have a well-tested, well-formed state. And this is a big problem. And it's why, for example, I see a lot of undergraduates running Dropbox in the background, which is probably not a great idea to have Git and Dropbox working at the same time. So Santiago went through thousands of Stack Overflow posts and basically took a collection of misfits that we identified and counted the number of posts against those misfits. And what I've been encouraging him to do, but he doesn't want to do yet because he's a responsible scientific graduate student and not an old curmudgeon like me, I want him to calculate the economic cost of the time that people have spent reading Stack Overflow posts about Git. But anyway, he did something much more practical, which was to build a reworked version of Git called Gitless that replaces those concepts by cleaner concepts that satisfy our criteria. And you can download this and play with it. And it's compatible with Git. So if you get bored with it and decide that you miss the complexity of Git, you can always go back to it. So as an example, if you take the concept of a branch whose purpose is to support an independent line of development, I won't go through the principle of Git, but it's quite complicated and it has some serious misfits. For example, if you have uncommitted changes, you can't switch branches. And in that case, you can stash, but you can't even stash if you have conflicts. And so what Santiago did was to say, well, to satisfy this purpose, a branch needs to have its own working directory. And when you switch branches, you should not only switch in the repository, but your whole working directory should simply switch. So under the covers, he hides that all from you. And when you say switch branch, you're just in a new working context. And when you switch back again, you're in your old working context. And you're not forced to get into some state in which you have files from multiple branches. And he did a user study. I think I'm running out of time, so I'm going to just point out that what he did was he did some measurements of the amount of time they spent on various tasks. Those slides I just rushed by that showed that indeed for many users Gitless saves the amount of time considerably. But I thought this was interesting. This is missing actually a crucial piece of the graphic that I mistakenly deleted last night. These should be high and these three should be low. Right? These are all bad things and these two are good things. And as you can see, the Git experts in this small group, well, they weren't that thrilled about Gitless. They found Gitless a little bit more difficult, a little bit more frustrating, and a lot more confusing than Git. I should say, these are people who use Git all the time, and we gave them about a 15-minute tutorial on Gitless. And Gitless was not quite as satisfying or efficient. But when we looked at Git regulars who use Git every day, things look a little bit different. They found Gitless more satisfying, a little bit less efficient because they weren't yet used to it perhaps, not so difficult, much less frustrating, and interestingly found it a little more confusing. Don't know what that's about. And then the novices, of course, the differences are exaggerated even more. So the way I would conclude is with this picture, that the way that I think we've often thought about the relationship between what users do and what programmers do is that there's a problem of programming which is sort of hard and technical and interesting, and this is what real people worry about. And then the UI design problem, which is soft and human and psychological, and no real computer scientist would touch this with a barge pole. And I would like to argue that this is a very mistaken way to think about design, and that in fact, when people think about the design of the user interface, what they're really doing is inventing concepts and their relationships to one another. And that activity is fundamental and determines not only the user experience, but it's going to determine the clarity of the underlying software and how easy that it is to build that in a modular and flexible way. And then what the programmer has to do essentially is representation design, to take those concepts and find a way to represent them in a way that's going to be compatible with performance and scalability and reliability and so on. And I don't want to say this is a small task. Of course, this is an enormous task if you're trying to do things in a cloud setting with distribution and so on. But I want to argue that these are separable and that the conceptual design phase is at least as important and should be recognized in software design as at least as important as what we normally mean by software design, which is a representation design problem. So that's all I have to say. So I'd be happy to take questions if there are any more. Yes?
So certainly in the examples that you gave, human-computer interaction was crucial to all of them, and you made it much more explicit. Have you thought about how you would apply concepts to cases where you don't have humans or non-HCI related?
So I think you could have concepts at the API level, right? A programmer is the user of an API and has to understand the concepts that the API presents, and the programmer typically has purposes that are fulfilled by the use of those API concepts. Although I haven't explored that, but I think there's something there to be explored. Yes, Yuri.
So I can imagine a situation where you have one concept fulfilling two purposes.
Yeah.
And that is because the purposes are related.
Right.
And if you were to actually separate it out and create two concepts, one for each purpose,
Yeah.
then you would get into a state where the two concepts are inconsistent. Your system's in an inconsistent state, right? In fact, that there was one concept actually kept it always consistent. And I think maybe the bigger point is that you could have two purposes that contradict each other. You can't satisfy them both. So have you thought about doing any kind of analysis over purposes to figure out, are these really the same purpose and they should have one concept, or are they contradictory?
Right. Well, if they're the same purpose, of course, there's only one of them. But I think you're right. The question of whether or not purposes are aligned is a very good one. And and it's something I'm very interested in and have thought about. Part of the problem is that purposes are not behavioral. Maybe I'll show you one or two slides on this, because I think this is a very interesting problem. I think that this gets to Laurie's question before, that really we have this sort of notion from engineering of efficiency in design. And as Karl Ulrich pointed out in a thesis that Yishai Feldman pointed me to, we love the fact that nail clippers look like this and not like this. And if we separated out each function that was necessary to make a nail clipper, this is what it would look like. The cutter, the spring, the bit that holds it in place, and so on, right? And this is clearly a superior design to this one. So the question is, when is it the case that we can actually, that we want to have this sort of merged design? My current hypothesis is it's when you can find some kind of abstract purpose that subsumes the multiple concrete purposes that you have. And so an example of that might be, in Amazon, for example, they have both wish lists and shopping lists, right? There what you really have is you really have one concept that's satisfying two purposes. They're rather different purposes. One is to remember things you want to buy later. The other is to tell your friends and family to buy things for you. And so what you could argue is that what you have in this case is two concrete purposes that can be characterized as an abstract purpose, which is to record items that you want. And a similar thing happens in Doodle. Scheduling a meeting and voting on a choice, right, can both be expressed as using the same concept. And I have other examples of very clever stuff done in Photoshop, but I can tell you about that later. But I think this question of when two purposes are sort of compatible enough to be merged is a very tricky and interesting one. Yes, Lee.
So I've been trying to decide since the beginning that have privacy.
Huh.
So your example of the particularly defined system really ignores the issue of privacy.
Mm-hmm.
I'm sort of annoyed by the fact that my phone is always telling me where my car is parked. So it obviously knows that I bought a ticket to where my car is parked. Let's compute these things together. It could be guaranteed this car.
Yes, right, exactly.
Same thing with the museum.
Yes.
So at some point later on, somebody's going to say, wait a minute, are you protecting the privacy of people who want that ticket to the museum?
Exactly.
So I'm trying to decide whether that fits into your notion of misfit.
Yeah, I think it's a classic misfit, right? Because and that's so the example of the propagated temporary file is exactly like that, right? So I have a backup system, right? And I say, the purpose of this backup system is to give me good backups, and the key property I want is that when a file goes, into my disk, it gets backed up, as fast as possible, right? And now what I do is I have a password program that keeps my passwords encrypted and creates a temporary file when I look at it that contains all the passwords in the clear, right? Sort of similar example to what you're talking about. And my backup system magically copies that file of passwords in the clear out into the backup, right? And there have been security attacks on this kind of thing. And I regard that as a classic misfit because in Alexander's terms, the specification was satisfied perfectly by the implementation. Right? The behavioral constraints were met in every case. Right? The problem is that the purpose was richer than we'd anticipated. The purpose had this particular quality of privacy that had not been considered. I'll give you another example, one I've used in previous talks about this. I wanted, as a photographer, to stick photos on the wall in my office, and so I considered the various implementations of that purpose, like putting thumbtacks through them, sticking them on the wall or whatever, and eventually decided on magnetic paint. But it didn't occur to me that magnetic paint would destroy the Wi-Fi in the room. Right? And I think you could reasonably say that nobody speccing a photo wall would say it should handle big photos, it should not damage the photos, and it should not interrupt your Wi-Fi. Right? And so there's an interesting thing here in that, that certain kinds of solutions will violate properties that you never even considered. Now, things like privacy, I think you're right. They should be sort of at the top of the checklist because we're familiar with so many misfits in that category. Yes, George.
So there's this problem of the purposes that you didn't think of, but in fact, for large software systems, one of the things we always talk about is the different stakeholders.
Right.
Who may in fact have not just different but conflicting.
Absolutely.
Purposes.
Yes. And yeah.
Aside from saying that, well, you should do some analysis to identify the conflict.
Right.
Which may be inevitable here. How does this fit into the...
So the way it fits is that I would say that is a classic example of overloading, that you have a concept that's serving purposes for different stakeholders that are in conflict. So I'll give you two examples of that. One is when you tag somebody in Facebook, it makes the image accessible not only to all your friends, but to all their friends too. Now, I would say that's not a purpose that they're going to be very happy with, by and large, right? So that means that if my boss is one of my friends and I go out drinking with Yuri, right, and he takes a photo of me, now my boss gets to see that photo the next day. Probably not what I wanted, right? Why is that? Because it's Facebook's purpose to increase the connectivity of their graph and to show as much stuff to everyone, right? And I think that that's quite insidious, that you often have purposes particularly, where two different stakeholders have. Another example, that Lee and Laurie probably know a lot more about than me, in the medical domain, electronic health record systems. It's well established that they drive nurses and doctors mad, right? Part of the reason is presumably that their purpose is not only to satisfy the needs of the nurses and doctors, but also to satisfy the needs of the administration of the hospital and the insurance companies, who want things documented, who want to be protected against libel suits, who want to be able to do analysis, blah, 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 all of which are at variance with what the doctor wants to do, which is spending more time with the patient. And I'm not saying that you can resolve these conflicts, but all I'm saying is that at least if we could articulate the fact that a concept is serving multiple purposes and the conflict exists, we could do better at resolving it.